This puzzle is called Christmas Camel by Panthera. Got it from the Sudoku testing submission channel of the CTC community Discord. Let's take a look at it. So this is a Japanese sum puzzle. If you haven't done one, but you have done what's called like a nonogram puzzle, which is where they, instead of sums out on the outside, it'll just say like the number of cells to color. And then you paint in a bunch of cells. I don't know. I'm not artistic enough to just quickly make a picture. But if if you've done that, it's basically the same as this, except this has another added layer of the Sudoku-ness of it on top. So the clues outside the grid indicate the sums of the contiguous runs found in that row or column that must be shaded the color. Yeah, must be shaded the color of the clue. There must be an unshaded cell between the runs of the same color. If a row or column is unclued, there's no shading in that row or column. So what that means is, let's look at this row. There's going to be a bunch of cells somewhere that sum up to 35. Let's say it's like that. And again, in this row, there's going to be 15, so it could be like that, for instance. Now, in a row or column with multiples, so let's get rid of this real quick. In this row, we're going to have a segment that sums to 1, so let's say like that. Then we need to have at least one empty space. We could have multiples, but we need at least one, so let's just say like this. Then we're going to have some digits that add up to 12. Then we're going to have at least one space, and of course in this random configuration I did, we don't have room for that, but that's okay. Or we don't have room for more than one, I mean. And then we have one space that adds up to 8. This would be valid if, we put in numbers that actually worked. Same for this, although there only has to be one gap. So we have 39, which could be like this, and then we have a space, at least one space, and then we have a sum of 3. So yeah, let's give it a try. I don't really know how hard this puzzle is. Yeah, it was just posted this morning, so yeah, just can't really expect the number of solves to indicate the difficulty yet. But I'll put a link to the puzzle down below if you want to give it a try yourself. Let's get going, I guess. So the first thing I see is 41. That's going to be hugely important. So there's a secret, as Simon calls it, but a full row, a full column, or a 3x3 box has the digits 1 to 9 exactly once each. If you add up the digits 1 to 9, you get 45. So that means the sum of the digits in each row, in each column, and in each 3x3 box, no matter which row or column or 3x3 box you select, is always going to be 45. Which means we're going to be coloring almost all of the digits in this row. We're going to be leaving off a sum of 4, which could be 2 digits. It could be 3 and a 1 to add up to 4. But we know at least these are going to be highlighted. We could put like let's say a 1, 3 over here and highlight these. But we're going to at least need this kind of base middle bit highlighted. 35 is similar. You can make 35 in just 5 digits if you go 5, 6, 7, 8, 9. So the way that I do it is kind of the same way I solve nonograms, although I haven't solved one in quite a while, is I highlight from the left and highlight from the right, and if there's any overlap, that's where you can color in. So we know that this is a minimum of 5 digits, so we highlight from the left, and we see it touches the middle square. Highlight from the right, touches the middle square, so that one must be filled in no matter what. 15 can be done in 2. 29 can be done in 4, and unfortunately 4 does not quite have an overlap. Yeah, so we can't quite get any information there. Let's take a look at this one. 39 plus a 3 is going to be hugely influential, I think. So 39 must be at least 6, so we can do that. So 6 is going to at least take these 3. Then we need a space, and then it needs to have a sum of 3. Now, a sum of 3 could be just the number 3, or it could be the number 1 and 2, both. Sorry, 1 second. My throat is really scratchy this morning for some reason. I'm sorry about that. Hopefully I muted there. I think I did. So, if we sum up both of these together, that's 42. Is there any way can we force... I think we do force this. No, so we know in full this column is going to sum up to 45. The shaded bits are going to add up to 42, and the unshaded bits are going to add up to 3. So we're going to have a string of... Oh no, but the unshaded bits don't have to be together. So, yeah, I think that either the unshaded bit or this 3 are one of them is going to be a 1 and 2, one of them is going to be the number 3, because they can't both be the number 3. They can't both be the numbers 1 and 2 both. Uh, so one of them is going to be the pair, one of them is going to be just a single digit. Now we don't know which is which. But that does mean that that 39 is going to take the full... is going to be the 6 digits, because we need 3 cells to sum up to 6. The unshaded 3 and then the shaded 3. But that doesn't actually necessarily mean that much. Let me think about this. So we could do it like this: 1, 3, 2, and have these be unshaded. 1 second. I think I'm gonna switch these to just be pink because I like having gray as an option. So we could do something like this, in which case all of these are pink. We could, we could also do something like this and have it unshaded up there. But yeah, or we could even do... Yeah, I don't think there's much difference actually. So I think no matter what, we take these cells, I think is what we come up with. That we need at least 1 cell over here, then a space. We need at least 2 cells, and then we need 6 on this side. 6 on this side means this overlap of 5 is where we can color. And then there's a 3 down here, but it could be both of these, it could be one of these. We don't know. I think that's right. And so now we can look back at this 35, and we only have 1 contiguous run. Contiguous just means, like, connected. So this 35 must be all together. Now this could be up to 7 cells, because we need 10 unshaded in this, so it could be like this. It could be like this. There's no cells yet that we know are not shaded. But what we can do in the 15 row, the maximum number for 15 is 5 cells. If you take 1, 2, 3, 4, 5, add them up, you get 15. So the most this could be is 5 cells in any one direction. So the farthest left this could be is like this. So these two must be unshaded no matter what. We can't put a digit, or we can't put a shaded digit over there. Which, oh, maybe this one is more constrained. I don't know. 29. Let's see. Needs, oh, it is still 7. Could still be 7 cells, because it could be 7 and 9 unshaded, and that would just be the 2 unshaded cells to make up the 16 unshaded. Okay. Do we know? Let's see this. Could this be unshaded? I think it could. We could easily make 15 right here. I think that would be fine. 9 could be made up here. That wouldn't be too difficult. And 17 could be made down here. But also we could do like 9. We could do 9 here and 17 down here, or 9 here and 17 down here. I think basically every option for this column works, unfortunately. This adds up to 39, and there's 1 gap. Okay, so this is something. So is it possible to have both of them down here? If we did 2 and then a space and then 2, we can't do 26 and 2. We need at least 4 for 26. We need at least 2 for 13. So this gap is going to have to be included in the gap between the two sections here. So we have a 13 up here, maybe not all 3 cells, but at least 2 of them, so that we can do this. So it's at least a pair. And 26 needs at least 4, I said. So it's going to have an overlap of at least 3, no matter how we arrange it. It could be all 5 cells. It could be all 5. We don't know. But yeah, it could even be something like this with a big gap in between. So we just don't know quite how it's going to work, but we do know a bit. And that actually gives us a huge amount of information with this 29 must connect across here, which means this is unshaded, because this is going to be, we said there needs to be at least 2 cells on the outside, so even if we started here and went right as far as we could, we would not quite hit that cell. So that's good. A little bit of information. I don't see if this helps us directly or immediately, because this 4 can basically be anywhere. It could just be 1 cell. Maybe not there. It couldn't be 1 cell there, because that would be a 4 in the 1 section, which wouldn't work, but it could be 4 basically anywhere else. I guess not there either, but that doesn't really matter. Okay. Okay, do we know a little bit more about this 917? This can't be if this was filled, this couldn't be 9 any longer, because you can make 9 in 3 cells, but you can't make 9 in 4 cells. But that doesn't, I don't know if that really helps at all. Maybe this 10, maybe it helps with this 10, or this 10, 8, 5, I should say. So we're going to have some amount over here that's going to sum up to 10, then we're going to have a gap somewhere in here. Now, is it possible that this is the 8? I think if this could be the end of the 8, or just literally just 8, the number 8, then the gap, no, it couldn't, we can't have a 1, this can't be a shaded 5. If this was a shaded 5, then we would break the 4 column, which at most has a shaded 4. So we know that this isn't part of the 8. This must be part of the 5. Yeah, because if this was part of the 8, this is shaded. Sorry, this is unshaded, then this is going to be a single 5. So this is part of the 5, which means it can't reach here, because it can at most go in 1 cell in both directions if it was a pair that adds up to 5. So this is part of the 5. Let's just write that in real quick. Can we make... No, we can't really fill in that this is part of the 10. So if this is 5, let's just say this is 5, a gap, then we have something that adds up to 6, but, or sorry, adds up to 8, but could just be a single cell, and then a gap, and then we have a couple cells that add up to 10. That doesn't necessarily help all that much. But we do know that this is part of the 5, at least, the 5 sum. I don't know if we know much more than that, though. And this, although it has a lot of gaps, all the numbers are quite low. It could all be 1 cell totals, just like the number 6, and then the number 3 a little bit later, and then the number 1 a bit later. Maybe looking at the number 1 is where we need to look? No, maybe not. I guess this can't be the number 1. That's something. This can't be shaded anymore. Because if it's shaded, it must be the number 1 for this row. If the cell's shaded, it needs to be a 1 for over here, but it needs to be part of a 4 sum over here, and we can't make this a 3 and be part of the sum anymore. So this is unshaded, which does help a little bit. We now have a little bit more information there, I guess. Oh, this could be the 3, couldn't it? This could be 1 2 pair, and then a space, and then make a 12 pair down here. It would be very, very constricted, but I think it would be possible. Okay, is there a column I've missed? Sorry if you can hear my chair, it is quite squeaky, and especially when I start, like, getting stuck and lean back a little bit, it squeaks a lot. If I'm really concentrating on the puzzle, I can sit pretty still, but... Okay, 7, does 7 have to be up here? No, it could literally just be the number 7, let's say here, and then the number 1 down here somewhere. And this spot is pretty tempting for the number 1, but it could just be a number 1 right here and be part of like a 1-4 to sum up to 5. Likewise, this does seem tempting to put the 1 in because we have a 1 in both sections, but it could be a 1 right here and just be part of the 39. Actually, it could not be part of the 39 because the 1, 2, 3s in this column are part of this 3 or the unshaded 3. But it could... So could this be shaded at all? If this is shaded, this has to be a 1 for the row. If this is shaded, it has to be a 1. But we said, which forces this to be a 3 down here. Just a 3 because it can no longer be a pair. So let's just say it goes here, it doesn't matter exactly. Then we have to have an unshaded bit, and the unshaded bit has to sum to 3, but it can't use a 1 and it can't use a 3. Which means it can't be the single digit and it also can't be the pair, which means, yeah, I don't think this can be shaded. Because if this is shaded... Let me go through that again. I'm not 100% sure that I convinced myself. Okay, so if this is shaded, this must be a 1 because it must be the last segment of row 1. The last segment of row 1 has to literally just be exactly the number 1 and that's it. So we can even color those in, but that doesn't really matter for this. So now we look at column 7. We need to make a 3. We need to make a 3 segment down here. Actually down here somewhere. And we can't do 1, 2 any longer because we just used the 1. So we have a 3 somewhere. Let's just put it here. It doesn't matter exactly where. It could be here as well. Now we need a gap between the 39 and the 3. The gap has to sum up to 3 as well. It cannot be a single digit adding to 3 because we've just used the 3, and it can't be a pair of digits summing to 3 because we've used the 1, so it can't be 1, 2. Yeah, I don't think this can be a 1 actually. So this is shaded, which means we now have a shaded cell up here and a shaded cell down here between the 39 and the... And this, yeah, this must be at least 6, so let's color that in first. We have a shaded cell up here, and we need a shaded cell after the pink segment, and then we need a colored in segment. Yeah, it must just be like this, because we have 2. This is a 1, 2 pair. We said this couldn't be a 1, so this must be a 2, this must be a 1. We actually have some digits now after 18 minutes. And then this is just going to add to 39. That's pretty... Can I color these in? I can make them a little bit darker. What if I do black? I can kind of do that. Like, that definitely makes me not want to look at it as much. That's helpful. So this is definitely part of the 3 segment. It couldn't be part of the 1 segment. So these are shaded, and we can't have anything after the 3, so this is shaded as well. So this is done. This 6 could be over here. Could be a 2, 4, or could just be the number 6. That would be fine. We know this is part of the 11, and this is part of the 14. They can't connect, because you can't have 6 digits. And even if you could, where would you put the 11 if this was the 14? You would have to put it in a single cell, so that doesn't really matter. Okay, 29. Oh no, we already figured that one out. This could come over here, that would be fine. No, it could still be 7 digits over here. Or 7 cells over here. 7 digits and 7 cells. Okay, what about... Okay, so could this... If this was 1, this could be 1, this could be 3, and this could be 6. I think that would work. Or 6. Actually, this 7 can't be a 6. Okay, let me look at this cell. This 7 can't be a 6-1 pair because we need just a 1 off by itself down here somewhere, or I guess it could be right here even. We need somewhere in this column, we need a 1 just sitting by itself. That's what this is going to be, is just going to be a 1. So this 7 can't be a 6-1 pair. Oh no, but this could be shaded still. This could be like a 5, well, it couldn't be 5-1. It could be, actually can't be 5-1 or 4-2. Maybe this is more complicated than I thought. Okay. There's multiple axes to this. Okay, let's look at this. Let's look at row 1 first. This 6. Theoretically, in a totally blank grid, it could either be the number 6, a pair of 1 and 5 adding to 6, or a pair of 2, 4 adding to 6. Those are the 3 options for 6 in general in a Japanese sums. But in this row, we need a 1 somewhere over here that is not associated with the 6. So we're using up our 1, and we've already typed in 2, so we're using up our 2. That means this is just a 6. It can't be the 1, 5, it can't be the 2, 4, so this is just the 6. That's an important thing to note. So this 6 is just the number 6, and actually this 3 is just the number 3 because it cannot be a 1, 2 pair. Because, well, we've used the 1 in the row from the very beginning. Or we've claimed the 1 in the row, I should say. We haven't put it anywhere, but we know we've reserved it for its own segment. Okay, so this 6 cannot be part of this 7. Because if this 6 was part of this 7, we would need another 1 in this column. And this column's 1 is also reserved for its own special segment elsewhere. So that means this is not shaded. If this was shaded, this would have to be the 6. And we've said that, and then we would have to use the 1. And then at that point, this 1 segment would not be fillable. I think that all was true. So this is unshaded. So now this is pretty constricted. If we could unshade this, this would be pretty constricted. Unfortunately, we can't unshade that. Okay, how about this? Could this be shaded? I don't think so. And maybe... No, this one could be, I think. But this one I don't think can be shaded. If this is shaded, it must be part of the 6. And we've just gone through logic saying the 6 must be the number 6. It can't be a pair adding to 6. Which means this must be the number 6, but the first segment in the column adds up to 3, and 6 is greater than 3, so that's not going to work. So that must be unshaded. But still, this could be a 1, like in a very constricted world, this could be the 1, 2 adding up to 3. That would be possible. And then have 12 be down here somewhere. Be like 3, 9 down here. Actually, no, that's no longer possible. Because if we reach into this column, it has to be the 1. It has to just be the number 1. So this must be part of the 12, which means the 3 is up here. Because this can't be 12. Because if this reaches in here, this would be a 1, and this would be an 11. Obviously that doesn't work. Actually, we can say this is a 2, 3, or 5, just to totally change gears here. Because this is part of the 5 segment, which means it's theoretically the number 5, a sum of 2 and 3, or a sum of 1 and 4. We have a 1 in the row, so it can't be 1 and 4. So it's either the 5, just the 5, or 2 and 3 summing to 5. So that should be correct. Which might... No, it could theoretically still be 2 plus 7 plus 8 plus 9 to be 26, which could be like this. Okay, so could this be shaded at all? Could this be shaded at all? If this is shaded, this is the number 1, and it must be part of this 12 segment. We need at least 3 cells to sum up to 11 if one of them is a 1, because you need 1 and then you need 2 digits adding up to 10. But once we go 3, then we're going to have to go 5. And 5 is a minimum of 15, which we kind of talked about here. With that row, I mean. So, if this was shaded, this would be a run of at least 5 cells, which would sum to at least 15, which is greater than 12. Therefore, that's unshaded. And that actually got me thinking about this segment here. So theoretically, in like an empty grid, 26 could be made in just 4 cells, and I just talked about how it could be done right here. 2, 7, 8, 9 would work just fine. But if it comes down here and goes into the final row, row 9, it must be a 1. If this is shaded, if this is shaded, this must be a 1. But at that point, even if we added a 5, an 8, and a 9, that's only 23, which means it has to take this cell as well. So if it takes row 9, it must also take row 5. But the options at the beginning were it either takes row 5 or row 9, so no matter what, it's going to take row 5. Because if it doesn't take row 9, it also needs to take row 5. So this is just always shaded. Now this could be shaded or not, we don't know. Yeah, we don't know, but it's one of the two. This 41 row, yeah, it could be the number 4 right here and then have the whole rest of the row shaded. I think that would work just fine. The 4 could be anywhere over here. I guess, this could be shaded. This could be shaded. I said if this was shaded, this would have to be the 4 and unshaded over here. But this could be like part of a 1, this could be part of a 1, 3 over here to sum up to 4 and not conflict with the unshaded 4 over here. I think that would work just fine. I was just thinking like, wait a minute, we just said 4 had to be used over here if this was shaded, but it doesn't actually break anything, unfortunately. Breaking things is how we learn. Does this have to be the 6? I don't think so, because this could be 6, 3, 1 like this. No, it couldn't. Could this be unshaded? That's the question. Could the black cell be unshaded? That would force these in like this, which looks good for these two columns, but this column is now broken because this is shaded, but the first shaded segment in this column has to add up to just 5. So this must be shaded, which means it must be a 6. Which unfortunately releases all the pressure we had on this row. Because now we need 3 and 1, which can go anywhere. Yeah, this could be 3, 1, or we could have a 1 here and put the 3 anywhere in this group of cells. Okay, what about this? This is a 6. This could be 7. This would just sum up to 13, or this could be 2 digits that add up to 7. I think either one of those would be fine. Actually, okay, I don't think this changes that, but we do now know, or know now, either way, I guess, that this isn't the only unshaded cell in the column. We need at least 2 unshaded cells, because these 2 digits add up to 39, which means, since the full column is 45, that means we have a total of 6 unshaded. We've just used the digit 6, which means that we can't just use the singular number to be the 6 unshaded sum. We need 2 or more. It could be 1, 2, 3, or it could be 1, 5, or 2, 4. So there's a few options left. But it does mean something is shaded. So one of these two is shaded at least. If this is shaded, then this is shaded. Does that do anything? If this is shaded, this is a 7. Which doesn't really do anything either. Okay, let's look at this. Again, we've kind of looked at this a couple times. Oh, this is done. We did finish this one, so that can be marked off. So the 3, this can't be the 3 because we can't fit 12 down here. So this is part of the 12, which means the 3 is in one or both of these cells. So this could be a 1-2 pair, or this could just be one of these is a number 3. But the 12 could go like this. This could be 12, and then the unshaded, and then a shaded 3. Which would actually go well with the shaded 7 here, to sum up to 10. That doesn't... Yeah, it doesn't break anything. I was thinking maybe it did, but I don't think it does. So this is part of the 5. So this is either a 4 or a 5. Because it can't be 2, 3, or 1, but it could be 4 plus 1, or it could just be the number 5. Okay. We know this is part of the 14, but that could be these two, and then the 11 could be, you could know, kind of anything. This could be 2, 4 as the 6. This could be 2, 4, which would actually work with the 4. Then this could be a 6 for the 8, and that would work just fine. Could these all be in the same group? If this is shaded, let's make, I don't know if you can even see that. Okay, so if this is shaded, this is all the same segment, of course. Which means this must be the 17 segment, because we can't have 4 digits adding up to 9. 1 plus 2 plus 3 plus 4 equals 10. So if this is shaded, this adds up to, this is the 17, and there could be another cell of the 17. That's fine. But then we need to add a 9 segment before that, so we need an unshaded bit to separate. Then we need a shaded bit, and that makes this the 9. Just a singular 9, which then breaks this first row, because we can only use these very small digits in the first row. So this can't be shaded. Maybe we could have done this quite a while earlier, actually. Maybe not, because we needed to find out kind of more about this first row. I'm not sure, but this must be unshaded, which means all of those are unshaded. 9 comes up here in some amount of cells. This could be a 3, like a 3, 2, 4 or 3, 1, 5, or both triplets that add to 9, so that could work. I guess this needs to be shaded, because 15 needs at least 2 cells. This 17 could just be 2 cells if this was 8, 9, but it could also be as many as 4 cells. If it comes down to here, it must be part of the 6, because this must be part of the 5. Is that a problem for any reason? Not that I see. What's 17 plus 9 is 26, which means there's 19 cells of unshadedness, which means you need at least 3 unshaded cells. That unfortunately does not. We have 2 of them, so there's at least 1 more unshaded cell. That doesn't really say that much. It just basically means we can't have both of these extend all the way. But one of them could just fine, or neither of them. But not both of them. So we learned a little bit. This is tricky. I'm not. Maybe once I get a little bit more of a breakthrough, stuff will start falling into place. But this is tricky. This is gonna take a while. This 29. I guess we kind of already looked at this a bit. At least one of these two is shaded, if not both. If just one of them is shaded, then it's a 7-9. If both of them are shaded, it could basically be anything. Sorry, if both of them are unshaded, then they could basically be anything. So this 3... One of these is a 3. We now know that, like, we now have a wall in between. So one of these is a 3. Or both, summing to 3. This could be 5, this could be 9 down here with an 8. No, we can't have an 8 shaded in here. Could this be part of the 5? If this is 2 digits adding to 5, then we need 1 or 2 digits down here adding to 9. But we can't have any... there's no combinations of digits that we could have in here that add up to 9. The biggest digit we could have here is a 6. But then we've said many times that if we reach down into row 9, it has to be a 1. And that obviously is only 7. So I think this must be part of the 9, which means the 5 is up here. Yeah, I think that's true. Oh, what about this column? 17 and 7. This is a 7. So it could reach down here and be 1, 2, 4, triple. But neither of these could be shaded. Okay, that's definitely something. Now, this could be shaded or unshaded, we don't know. Now this 17 must be at least 2 cells. This could be 9, 8, and match up with this 8 right here. But this must be part of the 8. This is part of the 10, we've said that, because it's at the beginning. We can't put another segment before it. This must be part of the 5 because it's at the end, which means we must have a gap between these. If we combined these, then that would break, because this is the part of the 8, this is part of the 5. So this must be unshaded, which means this must just be a 9 for this column, and we just finished that one. And now we know where the 1 goes, because 3 only has... The 3 is going to basically take both of these. It's only going to be a singular 3, but we can't fit the 3, an unshaded buffer, and a 1 in just 2 cells. So this must be the 1, which finishes both of those. And that must be unshaded, which means this is a 5, because we've boxed it in. Okay, so now 8 could be 2. It could still be a segment of 2. And 10 could be even a segment of 3, I think, at this point. Although no, it could be 1, 2, 7 still. I was going to say, with both the 5 and the 6 taken, we're kind of running out of options for a triplet there. But it could be, I think, like 7, 2, 1. Although that would... I don't think actually that's possible, but I don't know if proving that's wrong gives us anything, so I'll just forget that for the moment. Oh, now the 17 can't be 2 digits because we have a 9 in the box, so it can't be 8, 9. So it must be 3, which shades this in, and this is a 3. So this is going to add to 14. I think I'm technically shading that in slightly early, but that's okay. This full segment adds to 17, so this adds to 14, and it can't have a 9, so it must be 6, 8. So we finished the 17, and we finished this 3, actually. Let's color that in. This could just be the 8, or this could be an 8, 2. If this is 8, 2, does that actually... Sorry, if this could be just the 8, or it could be 6, 2. 8, 2 would not work. I don't know why I said that. If this was 6, 2, then the 2 would be part of the 5, which would then need a 2, 3, which wouldn't work because we've already used the 3 in the box. So I think this must be just the 8. And now we've done that, and now we still have a bunch of options over here, that's fine. Now this must be the 5, because we need a segment of 5, and we said it was above the wall. So we've done that one now. 9 is down here. Yeah, now that we've gotten kind of a foothold, this deduction here was the big one, and I think I could have gotten that actually probably pretty early on, unfortunately. I just am not super experienced with Japanese sums. It's at least in my experience, is a much more rare constraint. I really like it though. Before I found Sudoku, I really liked nonograms. So, I mean, obviously this speaks to it's very similar. It's a nonogram plus Sudoku, effectively, at least in my opinion. So I do really like this, but they seem very rare, so I don't have much experience with them. And I definitely missed this deduction here, which I think I could have done almost immediately. And this wall is just so huge with determining all these things up here. Maybe it wouldn't have saved me like, 35 minutes or whatever, but it would have saved me quite a bit of time learning about this wall early on. That's no matter, we got it here. So this can't be, no, this could still be 3 digits because it's 1, 2, 4. That works just fine. This can't be a pair though. The 17 can't be a pair because, we've used the 9. Sorry, I don't know, I had a brain fart. I selected the 9 and then all thought just left my head. So if this was a 17 pair, it would have to be 7, 8. But we've already... 7, 8. What is wrong with me? If this is a 17 pair, this must be 8, 9. What is wrong with my head now? It must be 8, 9 if it's a 17 pair. We've already used a 9, so it must be at least 3 cells. It could be 4, or it could be not 4. We don't know. But we know it's at least 3. 9 can't reach all the way down here. In fact, it can only be at most 3 cells. So we know these are shaded, which means one of these is the 1, but we don't know which. This could be a 6, or this could be a 2, 4, or we could just have a 6 right here, for example. That would all... There's several options for this. 11 could reach all the way over to the 4. Wait, no, could it reach all the way over to the 4? 11 and... 11 in... Oh, 8 could. I was going to say... So, but 11 in 4 cells is 1, 2, 3, 5. But this could... No, it can't be a pair. Because we've already used 1 and 3 in the box. So this must be shaded. If this was unshaded, this would all have to be 11, which would make this 1, 2, 3, 5, which would actually break the puzzle already because we can't... There'd be too many of these digits in the box. So anyway, this is unshaded. Now this could be the number 4, that would work fine. Or we could have the segment up here. This is part of the 12, but it could be a pair right here, which would work just fine. 3 is in one of these two, but it could also be a 1, 2 pair. This is 12, but it could come down here. This works fine. This is either 7 or a pair of digits that add up to 7, which would have to be 3, 4. Because it can't have a 6 because of the 6 here, and we have 5s looking over. In fact, we can kind of pencil mark 5s right there. So we have, yeah, this has to be, this would have to be a 3, 4 pair. If this was 3 long, this would have to be a 3, 4 pair. Which, does that do anything with the 10? Even if we proved it couldn't be 3 cells long, I don't think that really accomplishes anything. One of those is a 6. Okay, let's look at rows more. 14 could be even all the way over to here. Actually, it could be 4 cells. It could be all the way over, excuse me, like this. 41, basically however we want to do it. 15, basically however we want to do it. 35. Huh, okay, I'm stuck once again. Is it possible that this 7 is up here? If it's a singular 7, I don't see why that wouldn't work. It would mean this would have to be 3, 4, which would mean this would go at least this far. And would mean this would have to be a 1, 2. So we would have 1, 2, 3, 4 along here. We would have a 7 in one of these cells. I think that would work. I don't see why that would immediately break. Okay, let me think a second. If this is just a 4, this is just a 2, this is just a 6. I think that all works just fine. Actually, if this is a 4, if this is a shaded cell, it must be a 4, which means this needs to be shaded, it must be a 2, which means this needs to be shaded, and must be a 6. But then how does this 11 triple work? This has to be a sum that adds to 5, and we've already used 1, 2, 3, 4 here. This can't be 1, 2, 3, or 4. This is a minimum of 5, and we have 3 cells. We would already have 11 in just 2 of the cells. So if this is shaded, very quickly breaks the puzzle. We have too many low digits in this area. So this is unshaded. So now it's up there somewhere. One of these is the number 6, then, which doesn't cause all that many problems. If this is a 6, this must be a 2, which means these add up to 9, and that works just fine, I think. Let's see, 12, if this is... No, because this... 12 could be right here, then we would have an unshaded bit. Then we could have literally just the digit 8 right here, shaded in, as the last segment. And I think that would work. Sorry about my chair. I leaned back, the foolhardy attempt to get a little bit more comfortable. Okay, one is somewhere in here, which does kind of lend itself to the 1 to 3 pair, summing to 4. I'm trying to think if this could actually be 1, 2. If this is 1, 2, this needs to add to 10. So it'd have to be, could be 9. This can't be 9. So if this is 1, 2, let's just type this out to make it more clear. If this is a shaded 1, 2, this has to be part of a 10 sum. It can't be 2, 8 because we've used the 8. It can't be 1, 9 because that would be 15 in this segment. So this must be a 3 segment. But what digit goes here? What digits, what combinations could we even use that only have one of... Let me just... Why did that not work? Oh, I can't... Okay, 1 second. So we need 10 and 3 cells. Nothing works as much as as far as I can tell, nothing is working. But I don't want to type that in until this, and for whatever reason, my internet is being incredibly slow at the moment. Okay. I mean, it's always slow, but okay. So the options for 10 and 3 cells are 1, 2, 7, which wouldn't work because we've already used both 1 and 2. 1, 3, 6 doesn't work because we've used the 6. 1, 4, 5, which doesn't work because we've already put the 5, and 2, 3, 5, which doesn't work because we've already used the 5. So 1 and 2 does not work. So we have a 3 in here somewhere. And this could be 3, 7, and that does seem pretty handy. That would kind of close up everything very nicely. If this is a 3, if this is not 3, 7, we can't do a triple. No, we could do a triple. No, wait. Let me look at these options again. Oops. If we put the 3 here, this could be 2, 3. It can't be 2, 3, 5, and it can't be 1, 3, 6. Either one. So no matter what, this is a pair. No matter what we do, this is a pair. Oh, but okay. The more direct logic is, before we said that if this was a triple, this 13 was a triple, it had to be 6, 3, 4, because it couldn't be 6, 1, 6, because that would double the 6, obviously. It couldn't be 6, 2, 5, because we have 5s looking in. So it would have to be 6, 3, 4. It can no longer be 6, 3, 4 because we've used the 3 in the box. So this must be 6, 7, and now we have a shaded cell. And now this has to be part of a 10 segment. which could either be 127 or part of, sorry, it could either be part of 127 or 73. 73 is fairly clear how that would work. It would just be 73. But if we did 1, 2 and did this, then this would also have to be 1, 2 for the 3, which we just proved, obviously, it doesn't work. So this must be the 3 and must be shaded, which is going to unshade that. Finish that off. Finish that off. We can shade it in. We finish that whole row. This is unshaded because it needs to just be one contiguous segment. This is shaded, but this could be unshaded still. If this was 7, 8, this could be unshaded. 15, this works. 7 is down here now, although that doesn't put that much pressure on things. 12, this is 9, this is the 7, yeah. 17, I'm hoping for something that have not noticed. This is part of the 12, which we knew, and unfortunately, forcing that takes a little bit of pressure off. If we could have forced it not to be there, we could have, squeezed more stuff in down here, but that's not the case. Okay, 41, that's fine. If this is, no, this, sorry about that, had to sneeze real quick. If this is 2, this must be 3, and I think that breaks the puzzle. How does this being 2 work? It can't go 3 here because we've already used the 3 in the column, so it must go 3 here to make 5. But now, how does this column work? We need a segment of 1 as the last segment, but we've put a 3 down here, and that kind of blocks off everything. So this can't be a 2. Unfortunately, if this is a 3, this could be a shaded 2, and then that figures that out without interrupting this. Could this be shaded, though? If this was shaded, this must be a 3, 2. So it would have to be like this. And then this 2 does the same malarkey over here, where the last segment needs to be 1, but we have a 2 here blocking any more segments. So therefore, this is unshaded. So this could be 3, 2, or it could just be a 5. Either one of those is fine, but we know this is not part of it. So we have 7 up here. Is it possible that this is not the 1? Could we have 7, 1 like this? I think that works just fine, unfortunately. I don't see why that would not work. Okay. Do we know anything more about any of these segments? Oh, we finished the 13. There we go. That's something we can mark off, at least technically progress. This segment, okay, so this segment, if it's not a 1, 2, 4, if it's not 1, 2, 4, it must be 2, 5, because it cannot be 3, 4, or 1, 6. So this is either a 2, 5 or a 1, 2, 4. And I don't see really any problem with any of those. Okay. So this adds up to 10. How could we do how can we do 10 again? If this is just 10, if this is shaded, sorry, if this is shaded, then this will be 10. So how could we do 10? We can't do 1, 2, 7, we can't do 1, 3, 6, we can't do any of them because we can't use 5, 6, or 7, which means this is unshaded. Let's go through that again. So if this is shaded, these 3 add up to 10 because the full row adds up to 45, minus off the 35 segment, this would add to 10. We need a 5, 6, or a 7 in a segment, in a triplet that adds to 10. We have 3 cells, so that's a triplet. We can't use 5, we can't use 6, we can't use 7, therefore this cannot add to 10, which means this must be shaded, which means this must be a 1, 2, 3, 4, And this has to be the 3 because we have this 3 ruling out all along there. Okay, that's really good. And this must be 7, 8 then. I said that a little bit earlier, I think. That if this was unshaded, this would be 7, 8. Whoops, wrong one. There we go. So what's left? This is 5, 8, 9. And this 8 puts the 8 up there, so this must be the 9. Okay, well, is there anything else? I guess one of these is a 2 and a 1. This 1, 2 is gonna be, whoop, this 1, 2 is gonna be forced into here in the box, and then this must be a 4, 7. Then this is just a freebie. I think this is just a 9. Yep. And then this is a 4, 6. Okay. Now that we have this 3 here, this can't be a 1, 3 pair. It must just be the number 4, which makes this a 6, makes this a 4. That is really good news. Is it possible that this is a shaded 4? I went over this like 25 minutes ago. I don't think it's possible that this is a shaded 4. Let me think for a second. Yeah, if this is a shaded 4, then this has to all be one segment, because there's only one segment in the row. So now this is unshaded, and the unshaded bits have to add up to 4. So that's a 4, and now we have 2 4s in the row. So this cannot be a 4 because it would have to be shaded, and it would also have to be unshaded. So this is a 4, this is a shaded 4. And we finish this column. Nice. Okay, this 12. Is it possible that this is an 8? If it was an 8, it would have to be arranged like this. Now this needs to be part of the 12. It can't be 8, 4 because we just put the 4 in. It can't be 8, 1, 3 either as a triple because we've used the 1 up there. So that just can't work. So this must be 7, this must be 8. Now this could be a 5 or a pair that adds up to 5, I think. So we could write that in, I suppose. That doesn't hurt anything. Okay. But we did just get some information, I thought. But is it useful information? 29. Oh, this 15. We've filled it in, or we filled in the cells, but we haven't. I guess what we can do is that these two cells must add to 11. Right? Because this full segment adds to 15. 15 minus 4 is 11. These two must add to 11, so we can fill in the options. So this is 9, 8, or 6, and it can't be an 8. So this can't be a 3. So this is a 6 or a 9, this is a 2 or a 5. Okay. This 7 could still be 3. That's actually a little bit frustrating to me for whatever reason. I really feel like I should know that. But I don't know it yet. Okay, 17 could reach down to here. This could be 8, 2, and then a pair that adds to 9, I think. This can't be a 1, I suppose, because we have a singular 1 somewhere in this column. Okay, so if this is unshaded, let's just look at this row, or this column for a second. So the shaded bits, 13 plus 26, that adds up to 39. Unshaded sums to 6. So if this is unshaded, this is a 1, 2, 3, so this would have to be a 2, this would be a 1, this would be a 3. And if this was shaded, this would be a 1, this would have to be a 2, 4 pair. Which would make this a 4, this a 2, this a 5, this a 6. I don't think either of those are any sort of problem. Darn it. So it's so constricted here that either this pair or this triple adds up to 6. But somehow I just can't quite figure it out. Could this be 5, 2? Maybe we can figure that out? Not 5, 2, 3, 2. If this is 2, then all 3 of these would have to add up to 12. Can we do 12 and 4? Always has the 2. We said 3, 2. would have to be 145. Oh, no, that doesn't work. But that is... Okay, so if this is a 3, this has to be a 2. Which means this 2 is part of this 12. Oh, whoops, sorry. Part of this 12. Now these must either be 136 or 145. Those are the only options, but we have a 3 in the column. Which means this would have to be 145, but this is a 1 or 4. So we would have one or 4, or sorry, both 1 and 4 down here, and this one be unfillable. So this can't be a 3. So if this is a 3, this is a 2, and then this has way too many small digits in the column. This must be a 5. So then finally finishes off the 5 for us, not that one. Does that even get us anything? I'm so attracted to looking at this 7 clue, and we're not finding any information about it. And it is annoying. Okay, so this is a 2, this is a 3. I think that works just fine. In fact, one of these is a 3. Oh, and this is just a 4 by Sudoku. That's helpful. What's left in this column is 6, 9, 7? One of these being a 7? Ooh. Okay, that's interesting. That helps a lot, actually. So if this was a length 7 sequence, however we establish it, let's say it goes like this, then we said the outies have to sum to 16, or the unshaded have to sum to 16, which in 2 digits has to be 7 and 9. But this can't be a 7 or a 9 because we've pencil marked 7s here, and we have a 9 looking in, or we just have 9 kind of reserved in the box as well. So if there are only 2 unshaded cells, this is unfillable. So there must be 3 unshaded cells. Okay, 3 unshaded cells that add to 16. There's some options there. I guess one of these is a 1. If this was the 1, this would be an 8, this would be a 7, which would be a problem. But I think... Okay, so here we go. This is probably the easiest, this is the easiest place to look. So in this row, we need a sum of 4 for the unshaded cells. Sum of 4. So this cell is unshaded, so this is part of that. So it's either a 4 by itself, or it's part of a 1-2 pair. Sorry, a 1-3 pair. And it cannot be a 4, cannot be a 3. This must be a 1. Which means we need a 3 that's unshaded, which could be this 3, or it could be a 3 over here. I think we actually have progress on this first column now, unrelated to that. So we need a 7 segment and we need a 1 segment. The 1 segment is after the 7 segment, so the 1 can't be up here. So one of these is going to be a 1. But this can't be a 1 because we said the 1 must be down here. So we have basically a 1 in one of those 2 spots, and we have a 1 in one of these 2 spots. Well, there's only one overlapping cell there, so this can't be a 1. This must be the 1. Actually, this could be a 7 still, so we can't do that. We can't unshade this. But now one of these is a 7, and it's just the 7, just the number 7. Do we still not know anything about 6s in these columns? Does not look like it. Okay. That's fine. So either this is a 3 or this is a 3 and it's unshaded. This 3 is looking pretty inviting, but we don't actually know that. Okay. Oh, this can't be a 1 any longer because we have the 1 here now. One of these is a 7. If this is the 7, this is a 7, this is the 3. because this must be shaded. Which makes this a 5, which makes this a 6. That's all fine and dandy. Okay, the 8 is down here. Must be wholly in these two cells. So it's either the number 8, which works here. No, it doesn't. Where could we have just the number 8? If we have this as a single cell sum, sorry, my nose is getting stuffed now. If one of these is a single cell sum, it must be just the number 8, obviously. If we try to put it here, we need a 6 here, so that doesn't work. Whoops, too many windows open. I was just making sure OBS was still recording. If this is a single cell 8, it must be shaded because that's what a single cell 8 is meaning, which breaks the 6. So this can't be the 8. So that means this would be the 8. Now we have a sum of 12 already, and this has to sum to 11. Plus we have an unfilled cell. So this can't be a single 8. So it has to go through both cells. Once it reaches into here, it has to be a 6, so this has to be a 2. So we've actually finished off this row. Now this could be a 5 or 2 digits that add to 5. No, it can't be 2 digits that add to 5 because we've already ruled out both pairs. So this has to be a 5. Finally, we know that this is not 1, 2, 4. Okay, now this 2 looks up, which makes this 5, 6. Oh, this must be a 9, just by Sudoku. This 9 can't be in this column. This must be a 5 because of these 5s looking in. This is a 7, 8. This is a 2. Which means this can't be a 3 because the unshaded sum up to 16. If this was a 3, this would have to sum to 11 here. So this is 3. And the 3 was unshaded in this row, so this is shaded in. And this is actually looking more like a reindeer, isn't it? With some antlers here. And running. This is an 8. And this 2 resolves the 2, 5 in the middle. We've actually finished this off. No matter how we arrange these digits, we're going to have 1 and 3 unshaded, which will give us the right sum. Okay, we finished this one actually a long time ago. This must be the 7, because it needs to be by itself. This is unshaded. This adds to 12, and can't be 3, 9, can't be 5, 7, it must be 4, 8. And that's actually resolved by this 8 right there, which figures this out. This 7 is done. This 9 is not done. This is not done. This, okay, we need, what do we say, 16 on the outside, or 16 unshaded. We have 10 already, so this must be a 6. So we finished that. What are these digits? I guess I could look at that. This is 1, 3, 9. This can't be a 3. No, that's all we get. Okay, that's not very helpful. What about here? This is 4, 5, 6. Yeah, we have 6 here and here, which we could have just used those to place the 6. And this 5 looks up, makes that 4, 5. That can't be a 4. This 5 makes that 5, 8, actually. I think that's all the 5s now. 1, 2, 3, 1, 2, 3, 1, 2, 3. Yep. I don't think this can be a 1 or a 3 any longer. This is very constrained here. I think this 26, we have a 4 and a 5. That adds up to 9. Which means these two need to add up to 17. This must be 9, 8. Yeah, we'll look at the 14 in a second. So we just finished off this clue. What's left in this column is 1, 2, 3. Oh yeah, as we said, it's a triplet that adds to 6. So 1 and 3, this is a 2, this is a 1, this is a 3. Okay, so now we need another digit in this column that's shaded. So this is 6, we need a 6, so this is the 6. That sums to 14, so both of these are done. And this is shaded. And this already adds to 9, so that's shaded. That's done, and that adds to 12, so that's done. Okay, we have all the clues done. It's just basic Sudoku to finish off the puzzle. Okay, so this is a 2, 8. We have the 8 right here, which puts a lot of stuff arranged. This must be the 4. We have this 4 looking over. This is a 3. This is a 9, 7. The 8 that we Oh, actually, that 8 has been there a while, hasn't it? But it looks over nonetheless. This is 179, and we have a 7-9 looking here, so this is a 1, which figures out those. This pair is 1 and 9, actually, and no, we didn't no, we just placed the 1, that's what it was. I was looking at 9s, and we did type in the number 9, but we didn't actually figure it out. So this needs a 3, and we have a 3 right there. It also needs a 6, we can just fill that in the last spot. This needs a 4, we have a 4 over here. This needs a 7. Oh, no, we already have a 5. I was getting over antsy. We need an 8, and then we need a 2. There we go. Solution is correct. There we go. That was a toughie. I think I was a bit slow on this logic right here, ruling out this cell as being part of the shadedness. But we did get through it. I'm happy I finally did. That was a very fun puzzle. We have a very Christmassy theme here with the reindeer. Yeah, thank you very much for for the puzzle, Panthera. I cannot speak today, I guess. Thank you very much for the puzzle, Panthera, and thank you all for watching. I really enjoyed that, and nice little entry into the holiday times, I guess.